Hello chemists, this is Ms. Placino and you are watching a lab tutorial video for lab number 7, the analysis of antacids. Alright, I'm just going to kind of walk through the procedure of this lab. You are going to need to make a solution of sodium hydroxide, specifically 250 milliliters of a 0.5 molar solution. So you'll do the math and figure out what mass of sodium hydroxide needs to be weighed out. Sodium hydroxide is hygroscopic, meaning it's going to absorb water from the atmosphere. So as a result, you want to work with it fairly quickly to try to minimize exposure to the atmosphere. It'll actually gain mass as it's just sitting there, and if you leave it out long enough, it will look like it is melting. In reality, it's just absorbing water and dissolving. I stopped it too late, you can see. We're making a solution, so of course, use a volumetric flask. You want to carefully transfer all of the sodium hydroxide into the volumetric. Look at that focus. Nice. And then add water. Don't make the rookie mistake of filling up the volumetric flask to the fill line before all the solute is dissolved. Add a bunch of water, fill up the bulb halfway or so, and then swirl, swirl, swirl to get the solute dissolved. It's going to make your life a lot easier later. This takes me a while to do this, so I'm going to pause it and skip ahead so you don't have to watch that. Alright, you can see the solution is nice and clear, all the solute has dissolved, and as always, when it gets into the neck of the volumetric flask, go ahead and use the squeeze bottle so you can approach the fill line carefully. Even if you mess up making this solution a little bit, it's not the end of the world. We're going to need to standardize the sodium hydroxide solution because it is hygroscopic. We can't trust the mass that we are measuring, as it also includes the mass of water. Once you've got the solution capped, go ahead and shake it up, make it homogeneous. You are going to be transferring this to a plastic squeeze bottle, but there you have it, nice and clear. It's ready to go. All right. So to standardize the sodium hydroxide solution, we're going to use KHP, which stands for potassium hydrogen phthalate. Some people think that it is a potassium atom, a hydrogen atom, and a phosphorus atom bonded together. It is not that. Potassium hydrogen phthalate, or just simply KHP, is a fairly large organic molecule, and it is a weak acid. So when you're calculating its molar mass, maybe look it up and don't just add together potassium plus hydrogen plus phosphorus. That will not get you the right answer. You're going to calculate out the mass of KHP required to use about 15 milliliters of your 0.5 molar sodium hydroxide solution to standardize. You don't have to worry about getting that mass exactly, but you want to be pretty close. Cap it up, put it to the side, and you can transfer your KHP into an Erlenmeyer flask. I'm going to use a 250. Inevitably, some of the KHP will stick to the weigh boat. Use a little bit of water, get that off there. Not essential, but really, really thorough. All right. We're then going to pour about 100 milliliters of tap water on top of it. You don't have to measure this super carefully. We are never calculating the molarity of this solution. We just need to get the KHP to dissolve. And KHP is not super soluble, so instead of spending all day swirling it, let's use the stir bar. You can see that white little pill-looking thing in the Erlenmeyer flask. Ooh, look at it go. Get it to stir. You don't have to swirl. We can use the technology. All right, so we're going to be doing a titration. We need an indicator. We're going to use phenolphthalein for this reaction. Make your sophomore year chemistry teacher proud. What color will phenolphthalein turn when you put it in an acidic solution? Trick question. It is not going to change colors. Phenolphthalein is clear in an acidic solution. So I'm going to add 2, 3, maybe 4 drops of phenolphthalein. Ready to go. And as you can see, no color change. Make sure you've got it spinning fast enough so that you've got all those solute particles getting dissolved. You see I've created like a little vortex. It might still be stubborn if you need to turn the heat up to maybe like a 3 or a 4 to get those solute particles into solution. Feel free to do that. Do not let it boil. Okay, so I prepared my buret. I've gone ahead and rinsed it twice with water just to get any dissolve solutes out of there. And I've rinsed it once with my titrant, which in this case is the 0.5 molar sodium hydroxide solution. Once you fill up the buret, you almost inevitably get some air bubbles trapped into it. So before you titrate, let some of it drain out. You can see the little bubbles there. You might have to gently tap the tip of the buret to chase them out. Now you're ready to go. You want to make sure you do that after filling the buret. So let's look at a buret a little bit more closely. I don't know how well you can see, but each of those little tick marks, those little lines, represents 1/10 of a milliliter, so you should be estimating to the hundredths place. And if you take a look at the bottom of the meniscus, hopefully it's clear to see that we're between 2 and 3 milliliters. You always measure a buret with basically how much has gone. And maybe I've got, I don't know, about 2.4 in there. All right, now we're ready to titrate. Keep the stir function going. And we're going to add base. As we add the base, what color is this solution going to turn in the presence of phenolphthalein? Right now, not much of anything is occurring, but we're looking for a pink color to appear. Now, we know that this should take approximately 15 milliliters based on the calculation that you performed. Be patient with it. We do these titrations in triplicate because it is very likely that you are going to overshoot. Not the end of the world. First one gives you a pretty rough idea of how much titrant you will need. I don't know if it's starting to turn pink or I'm just like, hello there, I think I saw a little bit of it. There we go. And getting close. And you want to approach that endpoint slowly and gradually. You see the pink color stay and then disappear as it continues to spin. We would like the pink color to stay for 30 seconds. Ooh, getting close. For a total of 30 seconds. Oh, I overshot it. Well, what are you going to do? It happens. Again, so record the final volume of the buret. You would write that down. Make sure you're measuring to the correct number of significant figures. And that's it. Go ahead and you can just dump that down the drain. It's neutralized, so actually that's slightly basic. I'm going to come in a lot of contact with it, but touching it's not the end of the world. Rinse it out. You're ready to do the next one. After you've standardized the sodium hydroxide solution, you are going to analyze either Antacid A or B, the name brand or the generic, to see which one's the better value. I'll go ahead and use a generic for the time being. You'll get 2 tablets. I'm just going to do it with one. Take the mortar and pestle, and you're going to crush it up. The reason we crush up the tablet is to increase the surface area. As surface area increases, the rate of the chemical reaction that takes place should also increase. We are not a patient people, so get that ground up so that you're not spending all day waiting for it to react. We're going to use roughly 0.5 gram of antacid for each of our trials. Again, it's not super important that you have exactly 0.50 grams. Anywhere from like 0.45 to 0.55 grams is going to be perfectly adequate. So you'll measure it. You'd record the mass that you're using. Get it transferred to a 125 milliliter Erlenmeyer flask. And those whey boats are nice and flexible. And feel free to rinse the antacid tablet off of the whey boat into the Erlenmeyer flask. The presence of extra water isn't going to change anything. All right, we're going to basically drown our antacid tablet with acid. We're going to use 0.500 molar hydrochloric acid. Please do not put your pipette directly into the acid container. If your pipette is dirty, you're going to contaminate that whole thing. Pour off some of it into a beaker. This pipette has already been rinsed and cleaned with acid. And we're going to use 25 milliliters of 0.500 molar HCl. You might be thinking, well, wait, there's already some water in the Erlenmeyer flask. Isn't that going to change the molarity? I guess technically, yes, it will. But it's not going to change the number of moles of hydrochloric acid that you add. So don't worry about a little excess water being there. Measure out the 25 milliliters as carefully as you can. Make sure you're reading from eye level. Man, I nailed it. And you can let it drain by hitting the button. I guess like pressing that lever. Or you can just let gravity do the job. Either way is fine. As you take the acid and you react with the antacid tablet, you should have a little bit of bubbling occur. That bubbling is the active ingredient in the antacid reacting with a hydrochloric acid, and you'll know that the reaction is done when the bubbling stops. There'll still be some chunky stuff like white powder floating around in the Erlenmeyer flask. Your commercial pills, and a lot of your prescription pills for that matter, contain binders and active ingredients that just kind of make the tablet bigger and a little bit easier to handle. So it's normal that they're in there. Uh-oh, coughing. So we'll get that stirring. And in this case, instead of using phenolphthalein, that's not going to do the job. We're going to use bromthiamyl blue. Where did I put it? We'll use bromthiamyl blue. And we'll talk a little bit more about why the change in indicator when we talk about the pre-lab in more detail. Again, add a couple of drops. And we should have that solution turn yellow. Basically, what's happened is we've taken our antacid tablet and we've overwhelmed it with hydrochloric acid. We've neutralized every part of the antacid, and there's still excess acid left over. The reason we do this instead of titrating the antacid directly has to do with the fact that antacids contain buffers, and that would make determining the effectiveness of the antacid through direct titration a lot more difficult. So we're going to add in excess acid, use up all of the antacid, and now we have excess hydrochloric acid in solution, hence the yellow color of the bromthiamyl blue. Yeah, it looks like things are pretty well dissolved. No more bubbling. I look very serious. Yeah, again, you can still see those little things floating around. Inactive ingredient binders. That's okay. They're going to be there. They will not react with the acid. Their presence will not affect your data. You got some stuff kind of stuck on the side walls. Feel free to add a little bit more water, spray down the walls of the Erlenmeyer flask. Again, it's not going to change the number of moles of acid or the number of moles of antacid that were added. All right, let's get this titration going. Same deal. Measure the initial volume. Get the analyte stirring. You might want to lower your buret a little bit. Yeah, there we go. So that the tip of the buret is kind of like in the Erlenmeyer flask to avoid any spillage. And then back to titrating. So now we are adding sodium hydroxide to our acidic solution. We're going to try to neutralize the excess hydrochloric acid with the approximately 0.5 molar sodium hydroxide and kind of work backwards to figure out how many moles of hydrochloric acid were neutralized with the antacid. It might take a while. Be patient. And bromthiamyl blue is going to turn from yellow to blue when it reaches the endpoint. It can be a little tough to see. It'll kind of stay green for a moment. Please don't bring me your Erlenmeyer flask asking me, is this yellow, is this blue, or is this green? You know your colors. You're going to have to kind of make a judgment call. You can see we're getting close. Approach it a little bit more carefully. Try not to overshoot it. If you have OCD, you will have a love-hate relationship with titrations. You may want to slow it down, add a couple drops at a time. Look at that going, it's on drip mode. Showing off my titration skills. And you can see the blue color is persisting a little bit longer with each drop. We're approaching the equivalence point. Patience is a virtue. Ooh, real close. But same deal, you want that blue to persist for about 30 seconds or so. You can see I'm starting to get frustrated. And a frustrated chemist is a sloppy chemist, but that's okay. You'll do better. Okay. All right. That looks like it's going to stick. That might be a little over titrated, but again, we run things in triplicate to try to minimize these types of errors. And that's the gist of the lab. Record the final volume, and you are done.